Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question comes to us from Steve Price. Now, it's a little bit of a complicated question, and the answer, I'll give you the answer before I read the question. The answer is he's got RF in his equipment, and it's a grounding problem. So anyway, before I jump into this, because I'm going to take a little bit at a time, I want to pay special thanks to Mountain Moksha, who is one of my most recent patrons, having joined in just the last few days. A patron is somebody who throws in a few bucks a month to help support this channel. And if you too would like to become a patron, please go to patreon.com/KE0OG and pick a method that works for you. Let's take a look at his question now. He says, here is a summary of my question. Why are my 10th floor balcony antennas so erratic on 10 and 15 meters, but not on lower bands? Will I lose much if I can only use 10 watt CW signal instead of a 25 watt signal? Let's read the details here. Regarding the effective increase in power, I understand the rule that power must be quadrupled in order to make a signal appear louder to the listener. Just doubled will do it. That's 3 dB. 3 dB, which is half an S unit. But yeah, this is consistent with my experience. When I increase power from 5 to 25 watts, the 25 watts, and he's doing CW here, and CW stands for continuous wave, which is sort of an abbreviation for Morse code. The 25 watt garners significantly more contacts than do the 5 on similar conditions. Same antenna, same radio, same location of antenna, same time of day. However, what if I increase power from 5 watts to 10 watts? This only doubles the 5 watt signal. Again, that's 3 dB, which is half an S unit. Does that mean there is no perceived strength in the signal in the ear of the other operator? No. In fact, when you double a signal, the person who is listening will most certainly notice the volume difference. Let's see. But wait, there's more. 25 watts is less than 4 times greater than 10 watts. Does this mean that there is no perceived difference in strength between the 10 watt and the 25 watt signal? Certainly not. If that is so, does this mean that there is no perceived difference between the 5 watt and the 25 watt signals? Let's do the math on that. Here we're looking at power ratios. 25 watts to 10 watts, or 2.5. And now to convert that to dB, we're going to take the log base 10 of 2.5 and multiply that by 10. Okay, so we get out our handy calculator here, and we work from the inside out. 2.5 times, 2.5 log 10 times 3. Times 10. And we end up with almost 4 dB. Okay. Now, on many radios, most radios, 1 S unit is equal to 6 dB. So you're over half an S unit greater with that. Now, will that make any difference? Yes. Remember, every time you go up 3 dB, you double the power. Okay? And that's half an S unit on your receiver, and it is something that can make a difference between getting a contact and not getting a contact. I'd want to run at the 25 all the time unless you want to be literally QRP, which is 5 watts. Okay, so definitely there is a difference. It's worth going to the 25 watts if you can. Regarding why this matters to me, my antenna must go on a 4-foot by 7-foot 10th floor balcony. There is a wrought iron railing as well as plenty of rebar in the floor of the balcony and in the ceiling above you too, if you're not on the top floor. Okay, the apartment building itself is a steel structure. Most skyscrapers these days are. They have a steel frame or they will have concrete pillars with gobs and gobs of rebar in them. Okay, I primarily use 2 magnetic loops, a precise RF loop that will handle 25 watts of CW. It should very easily. And an Alex loop that will handle 10 watts of CW. Now, I have used the Alex loop. I have one. But I have not used the precise RF loop. I imagine they're all about the same. All of the mag loops are about equivalent to a dipole. And I know that from testing, okay? Of course, the mag loop is a compromised antenna. What you compromise is not power out, but you compromise on the bandwidth. So you have to constantly tune it across the band. It's very high Q. Let's see. Okay, the ham stick will handle 70. He has a ham stick too on 40 meters. The ham stick will handle 75 watts. I think it could handle more than that, but the ham sticks usually can go up about 100 watts. All the antennas are mounted above the wrought iron railing. Okay, so one of the problems is it's real hard to find something to ground to. Grounding to the railing does not mean you're going to ground to the rebar. And the rebar actually is set up deliberately in the concrete where they're not bound or welded to one another. And the reason for that is because they've got to be able to make nearly microscopic shifts as the wind blows and stuff like that. And if you weld that rebar together, it will crack the concrete. So they're not actually hooked together. So it's not like you've got the equivalent of an OOFR ground in there or something like that. But the building does act pretty much like a ground anyway. The problem is there's no way to connect to the rebar. Okay? Now, the big problem, here we go, is that none of my antennas will load up well on 15 meters when on the balcony. When I get them as close as I can to a low SWR, as measured by a Rig Expert antenna analyzer, the mag loops won't get below 2 to 2.5 SWR. That's very odd, because a mag loop should get down close to a 1-to-1 SWR. My Yaesu FT450D will sometimes, okay, now, here we go into the symptoms that are classic symptoms of RF coming back from the antenna and getting into the radio and causing what are euphemistically called unpredictable results. Okay, it will sometimes transmit for a short time, but will soon stop working. Why? You've got RF feeding back into the transmitter. The paddle key may send spurious dits, for example, then the rig will go silent. My laptop may also go blank. The rig seems to operate longer at 5 watts than at 25 watts. Those are all classic symptoms of RFI getting back into the radio. Okay? Now, the precise RF mag loop does the same on 17 meters. Same problem, same cause. However, the Alex loop, per the antenna analyzer, achieves an SWR of below 1.5 and seems to be able to transmit without any problems on 17, 15, and 17 meter ham sticks won't work on 15 and 17, nor will an MFJ 1622 apartment antenna, which is composed primarily of a ham stick. Okay, let's take a look at what's going on here. You're getting RF back into your radio. Now, you mentioned one antenna does a little differently from another. That's because they're placed differently. And so the path for the RF to get in and echo around your apartment is a little bit different. Now, there are a lot of things that you can do to suppress the RF. One of the simple ones is this MFJ 915. Right here, it's about $30, something like that. It's an RF isolator, 1.8 to 30 megahertz, and it can handle 1,500 watts. Okay, $59.95. You put this thing just before your rig, short cable from here to your rig, and then this goes to your antennas and stuff out there. This is the equivalent of putting 1,000,000 ferrite beads on your coax before it goes into your radio, which is the other thing you can do. The other thing that you can do is right at the antenna as it comes off. Remember, mag loops, the way they're constructed, they are balanced antennas, but they all have an SO239, and we feed them with unbalanced coax, and they don't have balance in them. So what you can do is either put a 1-to-1 bal in there, or wind maybe 9 or 10 loops of coax right there at the feed line input, okay, going into your cable back to where your radio is. And then maybe doing it again at the radio. Do that on each antenna, okay? And the antennas will still work fine. It won't affect the antenna at all, because what the antenna sees is what comes on the inside of that RF, okay? So now, as far as the ham stick is an unbalanced antenna, okay? And so you're feeding that, and you got to feed it against something. So there's got to be a counterpoise of some kind, which could be the balcony rail itself. But again, that's a great source of RF. So putting something like this isolator or something like that on your antenna will help. Another thing that will help is moving the antennas around and moving the cables around, moving your 450 to a new place. He says, thankfully, both mag loops work well on 20 and 30 meters. They both also load up well on 40 meters, but are so inefficient on those bands that I use a ham stick at 75 watts instead. I'm going to show you something here on the whiteboard. Let's take a plan view. We're going to look down at your apartment, and it's got underneath here a balcony, and here's your bedroom, and here's your station, and here's the bathroom, whatever it is. Okay, you've got this balcony right here. You've got several ways that you can mount that mag loop. If you mount it this way, you need to know that the radiation from that goes primarily out like this and out like this. You get very little radiation out that way. So orient your antenna so it is this way. And if you want, on your window here, you can put some aluminum foil, which will tend to reflect the signal, and the signal will go out more in that direction. You can actually rotate it to get different directions, and you might want to rotate it to find the one that gives you the least RFI. Now, there is another option. Let's look at a side view of your apartment. Okay, you've got a window or door and a balcony railing. Okay. Mount your antenna so that it comes out here like this, and this is flat. Not, it looks like it's pointed up, but it's flat, so that it's absolutely flat right here. This will give you a radiation pattern. Now looking at the plan view here, you've got this out here flat. It's going to radiate in all directions about equally. It will not radiate up very much, nor will it radiate down. Now again, you can do the thing with aluminum foil or something like that behind it on the windows so that it will reflect more than go into your room. So the horizontal will actually give you more coverage than the vertical will. Okay, let's take a look at the rest of the question here. He is able to get out on the different bands. He says he has problems with the mag loops tuning up on 40. He says they're so efficient on those bands that I use a ham stick at 85 watts instead. Now you know that with both of those, if you replace that coax loop with like a copper loop, like copper pipe, you can get copper pipe that's coiled and kind of straighten it out and get it into the right form. You're going to get a lot better response out of that. Now the thing that limits the power in these is not the loop itself, although if you do the copper, the loop has lower resistance, so you get higher efficiency. But if you look at the capacitors that are in use in those loops, they're just standard old capacitors. And arc over in the capacitor is the limiting factor on how much power you can put through one of those mag loops. Says the Alex loop is the only antenna I've taken into the field from a picnic table in a park away from metal obstructions. The Alex loop works well on 15 and 17 as well as the lower bands. The field rig is a Yaesu FD818ND, which I operate at 5 watts. Okay, you don't have the RF problem there. If you do, you can just kind of move the antenna a little bit. So to summarize, what is causing my antennas to be so unstable on 15 and 17 meters? RF in the shack. That's what's causing the problem. It is causing your equipment, your tuner and your radio, to operate unpredictably. Now note when you're using the loops, you should use the SWR meter that you have to tune that loop, but you should not be using an external antenna tuner. You shouldn't need it. You should be able to tune it down to close to 1-to-1. And why would the Alex loop be so much better than the precise RF loop on 17? Because they're in different places. You can't put them in the same place. Is there anything that I can do to correct this? If the 10-watt signal from the Alex loop is as effective as a 25-watt signal, we just showed it was not, should I just concentrate on that loop and not worry about the precise loop on 17? No, I really would recommend that you persevere with this RFI problem. You should be able to operate 100 watts out on the ham stick, okay? As long as you've got it tuned up right, you should be able to get about 100 watts out with one of those. Now those loop antennas, both of them, I believe are designed for QRP, and the same kind of thing goes for them. You've got to keep the RF out of the shack. He says, Dave, I realize this has been a bit of a slog for you to read. That's okay. I appreciate your knowledge and patience. Considering the proliferation of condominiums and apartments, I can't be the only person experiencing these problems. You are not by a long shot. There are a lot of people in your situation. Any insight you can give may help many hams. All the best. 73 from Steve, WB7DND. So there you have it. A look at the apartment antennas and some various things that you can do to keep the RF. If your equipment is behaving unpredictably, like extra dits or the laptop goes off or something like that, you've got RFI in the shack. That's RF bouncing around in there. And all that concrete has all that rebar inside, and it acts as a nice little Faraday cage to keep it there. So that's why you have to make special arrangements in order to keep the thing working. Often just moving things around will fix the problem. So there you have it. And if you would like to help support this channel financially, please go to dcasler.com/support and look for a way that works for you. Until we next meet, 73.